Good morning, good afternoon, good evening, depending on where you're located. My name is Olufunke Kofi, and I'm your moderator for this webinar. I work as principal researcher with the International Water Management Institute, and I co-lead the flagship 2 on water and land solutions for the CGIAR Research Program on water, land, and ecosystems, WLE. So welcome to the WLE webinar series on climate smart solutions to enhance ecosystem health and strengthen food, nutrition, and water security for all. This edition is webinar number 5, and it focuses on managing water for climate adaptation and mitigation. So you are welcome again. Kindly introduce yourself on the chat box by writing your name, the name of your organization, and email address. We will use that to identify you and to link up with you after the meeting. The webinar is on managing water for climate adaptation and mitigation. As we all know, climate actions on effective adaptation and mitigation pathways must align with predicted uncertainties and erratic patterns of rainfall intensity, duration, and variability. Climate change projections call for adaptation and mitigation measures at different scales and the use of integrated water solutions. Farmers in particular must adopt climate smart water solutions to be able to build resilience against climate change. So the objective of this session, therefore, is to highlight water management options for adaptation and mitigation, and to recommend actions for integrating such options into the broader development framework of sub-Saharan African countries. We are focusing particularly on sub-Saharan African countries, of course, with lessons drawn from Asia and other parts of the world, and lessons applicable to other parts of the world. So for this webinar, there are 3 parts. In the first part, the Ignite talk, we're going to listen to 2 experts who will tell us about climate change impact in Africa particularly, and introduce us to diverse water management options for adaptation and mitigation. The second part will be a panel discussion in response to the Ignite talk, and it will be coming from different perspectives. The third part is the Q&A, question and answer session, in which we really want to be interactive, want to engage with everyone. So we encourage you that as the presentation is going on, you can kindly add your questions to each of the panel in the Q&A box. Let your questions be on the Q&A box, and introduce yourself in the chat box. I will now introduce the first 2 speakers for the Ignite talk and invite them one after the other for their presentation. So the first person is Professor Kehinde Ogunjobi, who is the Director of Research at the West African Science Service Center on Climate Change and Adapted Land Use, WASCA, based in Burkina Faso. WASCA is set out to provide information and knowledge at the local, national, and regional levels to its West African member countries to be able to cope with the adverse impacts of climate change and devise integrated options to build up resilient and productive socio-ecological landscapes. After Professor Ogunjobi, the second speaker will be Dr. Sanders Ward, who is the coordinator of the Water Enabler Compact of the AFDB flagship program on technologies for African agriculture transformation. Sanders is leading this part of this program, contributing to what African Development Bank is doing in Africa, in many countries in Africa, and he will be sharing with us from his experience. So I now invite Professor Ogunjobi to take over and make his presentation. Over to you, Kenny.
Thank you very much, Funke, for that brief introduction. So again, it's my pleasure being here this afternoon to share some of the thoughts with you from WASCAL on a topic titled Climate Change Impact and Scenarios in Africa, Implication on Water Resource Management. I hope at the end of my discussion, I'll be able to ignite this discussion based on the output from my presentation. Let me quickly add that the presentation is also as a result of data mined from literature and also simulation carried out by myself and our colleague and scientists, at WASCAL. The presentation outline is as shown on the screen. Number one, my presentation will provide insight into the current and future climate and irrigation needs in Africa, and then narrow it down to share experience from West Africa, as Funke has rightly said in his introduction. And then we'll try to ignite our thought on projection result from SSP climate scenarios, and then its implication on water resources management. According to Al-Mazuri et al. Of 2020, here is a projection of the mean temperature over Africa under different SSP scenarios. And here we have done it, here is a literature mined for the projection of temperature over the region using ground observation of 1981 to 2010, and a projection from 2030 to 2090. My apologies on the quality of the graph, but here we have seen a consistent and robust warming over most parts of Africa under the three SSP scenarios of 2.6, 4.5, and 8.5 with different magnitude. The largest increase in mean temperature of about 5.6 degrees Celsius under the 5 to 8.5 scenario is likely to occur in the Northern Africa represented by NAF, and also in the Sahel region of the sub-Saharan region of our continent. And as a result of these, we see a relentless warming of hot extremes will likely become common and deadly in North Africa, in the Sahel region of Africa, Southwest of Africa, and Southeast African region, suggesting the need for precautionary measures to adaptation and mitigation measures against heat waves. And then here on the second slide on the projection is also projected changes in rainfall over the region. And also as expected here from projection, we see that projected annual mean rainfall have the tendencies of becoming warmer over the West African part of the region, of the continent, in the Central Africa, Northeast Africa, as well as the Central East Africa, and a drier condition in the Western Sahel as indicated, in the projection that you are seeing here. The increase in rainfall may reach as much as 30%, while decrease may reach as much as 20% under the SSP under the mean SSP of 5.0 to 8.5 scenario. In overall, it is suggested that by the end of 2021, it is expected that the part of Senegal, west of Mauritania, Tunisia, Morocco, North Algeria, Northern Libya, Namibia, and western part of South Africa will experience decrease in rainfall, whereas Niger, Chad, Sudan, Southern Egypt, Somalia, and Kenya will experience the largest rainfall increase. Now, narrowing down from projection carried out in West Africa by scientists at the Competence Center of WASCA, we also see that an observed regional warming over West Africa could reach as much as 0.8 to 1.2 degrees Celsius within the century from 2020 to 2100. Also in rainfall, we also observe recovery with much available average rainfall in the Sudano-Sahelian region of West Africa, while we also project a slight increase of the average rainfall in the Sudano-Sahelian region. But in the Guinea zone of West Africa, we see that there is a kind of a pseudo-temporary or pseudo-stationary pattern of rainfall in the century. We also observed that this will have an implication on the heat stress for water availability and livelihood, which is shown here. And we see a shift or an increase in the transhumance, increasing competition over natural resources such as land, water, etc., for even livestock. Here is a projected change in irrigated water needs over the region. And we also observe that a general decline in the basin scale irrigation potential in the event of large-scale irrigation is observed under the 2-degree global warming in West Africa. Running down to the conclusion, we see now that according to IPCC report, less rainfall is likely in drier months, which could increase drought in the region and present greater impact of both permanent and seasonal water resources, especially in the area, arid area and Horn of Africa. Climate change impact will also result in reduced in annual flow of the various river basins available, such as the Nile River Basin, the Niger River Basin, Volta Basin, according to simulation by Wascal and COC 2020. Climate change impact is seen to deteriorate water resource, resulting in numerous negative effects, such as increasing food insecurity, transboundary conflict, and rising health problems, among other social consequences. The impact of climate change on water resources will be significant in the entire continent. What is the way forward? Quickly, I want to say that we need to optimize and quick uptake of structural adaptation options in co-designing and co-implementation of decisions within the region. We have to improve on capacity building, gender equality, integrated transboundary and nexus approach, insurance scheme, natural-based solution needs to be intensified in the region in order to ameliorate or reduce the effect of these climate issues, in Africa. And we need to operationalize, operationalization must also involve sovereign wealth funding, private selection, competed with a global fund, because all adaptation options we have seen deemed well fitted for future climate of Africa that are aligned with sustainable and emerging goals of our countries. So here are some of our references that are noted, that are used during for this presentation. And at this stage, I want to thank you for this, and I hope I've ignited your thoughts and area of discussion as we move on. Thank you very much. Funke, back to you.
Thank you very much, Kenny. You have really ignited us a lot with all your findings. I will now call on Sandra to take us to some examples of water adaptation options for building resilience across scales. Sandra, over to you.
Yes, thank you very much. Thank you also very much, Professor Kinder, for that very nice overview of the changing climate and the potential impacts on the water resources. That's actually a very nice introduction to my short talk. I'm trying to move the slide. Yes, there it is. So yeah, we have a changing climate, and what are the impacts on the water resources? And Professor Kinder, you talked about the irrigation systems, but of course there's also the rain-fed systems, the wetland systems that where the water resources, the hydrological balance is changing. So major challenges in the rain-fed system are, of course, the rainfall patterns that change. There's a later onset, sometimes an earlier onset, shortened season, higher intensity, more uncertainty in the rainfall. That leads to prolonged droughts, drought spells, flood events, and the major users of the water resources are the farmers and of course the herdsmen that depend on the water resources. Irrigation systems, we've talked about. Increased water demands is certainly an issue. There's also reduced river discharges, but also, for example, lower levels in the rivers. So maybe extra pumping capacity is required, such as, for example, in the Senegal River Basin. It all leads to a reduced irrigation water availability, and that leads to possibly conflicts over the water resources and the distribution. Affected are the farmers, but also herdsmen that take water from the irrigation systems, and of course the domestic users. And then the third group I want to stress is the wetland systems. Lowered water levels, shortened flooding. If you think, for example, about the inner Niger Delta, there also the patterns are changing, and there's many people that depend on those water resources, like the fishermen, but also the farmers, for example, with the deep rise that are affected by the changing floods and water availability. Now, there's a lot of talking about climate smart technologies, adaptation options. And usually if you talk about them, you know, they're farm level solutions, improved varieties. There's a lot of new varieties being developed, introduced by the national centers, by the international centers. They have a shorter duration to be adapted to the shorter growing seasons. They are drought tolerant. Water conservation measures, soil and water conservation measures, so the zai pits, conturbance, mulching, etc. And of course, water productivity improvement. So trying to create more value from the water resources that are available. More local regional solutions are irrigation development, which is offered as a solution for climate change. Water storage from the small reservoirs, irrigation water savings at scheme levels, but also digging wells for watering crops, and for livestock. And finally, there's the landscape water management planning that is offered. Now, what are the challenges in scaling these solutions? What we have seen in many of the development projects is that adoption rates are actually very low. Often the solutions that are offered do not match the demand from the users. There's a focus on infrastructure, creating dams, creating canals, irrigation schemes, water retention structures. The actions are often not very sustainable. They're introduced, and what you see later is that they are not being used by the local population anymore, or the quality has deteriorated, that they can't be used anymore. It may also create unwanted impacts, and of course, one of the best examples is the saving water in irrigation. And what actually happens is that the areas are expanded, and that actually eventually more water is being used by the farmers. There's poor planning and integration in other initiatives, which doesn't help the integration. The actions are not supported by policies and regulations. So an action is introduced, but actually due to policies, the results are deteriorating. So there's no support from policies, laws, and regulations. Well, let me give you two projects in which I was involved in the recent years, and Funke introduced one of them, that was the Technologies for African Agricultural Transformation, scaling low-cost irrigation and water soil conservation technologies. So we have a whole range of technologies that we can scale. We do on-site demonstrations, on-farm demonstrations, and training of trainers. Let's say it's very much a technology approach, thinking that technologies are the solutions, and that will help to improve the productivity and ultimately the income of the farmers and the resilience to climate change. It's a very linear scaling model, pretty top down. What we see in the demonstration site is that the impact can be very high. We can triple crop yields in sorghum, for example, increase the water productivity. But what we see eventually is very low adaptation, unfortunately, around the demonstration sites. Another project which is pretty different, that was the Smart Valleys project. Smart Valleys is a low cost methodology for developing inland valleys. It's about creating the bunds, as can be shown on the picture. It's about land leveling and drainage canals, so it's semi-controlled, semi-water control. And the role of the project was the methodology, which had been developed before based on experiences working with farmers. And then facilitate the communities with the design of their system, the implementation, and the maintenance. So it was not bringing the technology, but much more in guiding the communities in developing developing the smart valleys, which went very well. We've seen very high impact. Also here, using rain-fed agriculture, the yields could double or triple the rice yields. And there was also higher adaptation rates around the sites and within the sites. So more and more farmers using this technology to manage the water resources and to increase the yields. So what is important in the projects that around climate action, the beneficiaries must be upfront and central always, as I've written on the top. It's really about when you develop the technologies, the beneficiaries are included in the process. So they should co-design, the researchers and the development project should co-design the climate smart water technologies. It's about involving the communities in developing community and landscape plans for water resources management, co-implementation of projects, climate smart water solutions. And what is very important, and that is what we do at the CG very much, include the marginalized groups in the decision-making processes so that no one is left behind. Climate change and climate action, I think there should be a paradigm change. So very much researchers, they like to develop their technologies and then bring it to the farmers and to the other beneficiaries, of course, to the livestock aquaculture. But very often we see that those technologies do not match what actually the beneficiaries require, and there's a low adaptation. So it should be upfront, and luckily we get more and more of such approaches, like, for example, scaling readiness, you know, that farmers are involved in the development and in the implementation of technologies, and that ensures the sustainability. That also means that the people that develop projects, they should also have this shift in change. That projects are not about creating infrastructure, but it's really about guiding communities and investing in climate smart water solutions. Using different indicators for success, so not the kilometers of canals that have been constructed, but the farmers that actually are using the climate smart water solutions. More time should be available to guide those processes, because it also ensures eventually sustainability of the project, and should be more focused on the people and the beneficiaries, and ensure that no one is left behind. So inclusive development throughout the project cycle. Thank you very much. If you have any questions, please put them in the Q&A at the bottom. Thank you very much. Back to you, Franca.
Thank you very much, Sander. Your presentation has actually complemented the first one of Professor Ogunjobi, and it shows to us that actually there are ways out. There are many options that we can adopt at different scales to be able to respond to those challenges that Professor Ogunjobi mentioned in his presentation. Thank you very much. We'll now move on to listen to two panelists and to tell us from their perspective how exactly can we approach these and what are the lessons that we can learn from their experiences. So the first person I want to introduce is Dr. Timo Gasbik, who is the first Secretary Water and Environment at the Embassy of the Kingdom of the Netherlands in Rwanda. His focus has been on integrated water resources management, water conservation, conflict management, and climate change and variability. And as we all know, that the Netherlands Ministry of Foreign Affairs supports development initiatives around water a lot. I'm sure he's going to tell us quite some things from his experience. The second person is Dr. Tamim, who from research perspective will be able to tell us a little bit more what it means to scale innovations that has to do with water adaptation options. Amin is a senior researcher that is leading IMI's agenda on scaling agricultural water management innovations, and he will be joining us as panelists. But let me go to Dr. Gasbik first and ask him some specific questions so that he can share his experience with us. We know that the Netherlands Ministry of Foreign Affairs actually supports water innovations globally. And from your experience, can you share with us how integrated approach like the landscape or intersectorial approach can actually help to support climate adaptation and mitigation from your experience? Thank you.
Thank you. Yeah, I think one key factor that needs to be taken into consideration, it's already been mentioned, but landscapes are used by people. So if we want landscapes to be climate adapted to climate change, we need to work with the people who use the land. We need to work with their livelihoods and their possibilities and constraints. And nothing that we design from outside will work if it doesn't fit in what people do. And the most vulnerable parts of the landscape are used by the most vulnerable people in general, who generally are subsistence or below subsistence level, who have very little room to invest. So if you want to make a difference at scale, you need to have measures that are affordable and scalable. And what I see with a lot of project measures is that they're fancy, they're really nice, but they're often too expensive for people to copy them. There's another interesting thing that I see now. There's a whole debate on irrigation efficiency, but at a catchment level, a lot of efficiency losses in irrigation actually come back into the groundwater. So at a catchment level, there's a risk that we end up working with very, very expensive technologies, which at a catchment level don't really make much of a difference. And I think we need to not just look at scheme levels, but also at a landscape level as a whole and see what really makes a difference there.
Okay, thank you very much. Now, maybe I can ask a follow-on question. Yeah, from the recommendations you are giving, what are some of the opportunities that you see happening to make it work in Africa, maybe beyond Africa? What are some of the opportunities and what are some of the challenges that you can think of, you can share with us?
I think opportunities are a key thing that was mentioned is evapotranspiration increases because it gets warmer, rainfall patterns change, and there's less infiltration, so there's more drought stress for crops. So I think the key thing is to keep as much of the rain on the land as possible. If you're in uphill areas, in the valleys it's a little different. And those are often measures that people can do by themselves. There are approaches that have been developed. There is, for example, the Plan Intégré du Paysan approach that's been developed in Burundi, which is one of the approaches that really works with farmers for them to come up with their own plans, and that scales. It works, it goes fast, and it's relatively cheap. I think those are ideas that we should work on actually.
Okay, thank you very much, Dr. Gaspi. Let me move on to Dr. Min. Min, okay, thank you very much. You have been working around innovation scaling, and you have quite some experience in that. So from your perspective, how can we actually remove some of the barriers that are involved in adopting these water adaptation options that we have heard on, that people have been talking about? How do we remove the barriers? How do we create enabling environments to enhance adoption of the climate change adaptation options?
I just go straight forward to the question. In order to address the systemic barriers and creating or improving enabling environment to climate change adaptation in general and water and irrigation in particular, it firstly requires investigating the factors that maintain the state or core of the system, but also create conditions for transformative system change. Based on this understanding, then strategically addressing them intentionally and also swiftly and also inclusively in order to shift the system in the new direction. These factors include policy, practices, resources, and also relationship among stakeholder and actor involved, power dynamic among those making decisions, practices and resources, etc. And stakeholders' mindsets, values, and beliefs. All these are roots and fundamental for systemic changes. And if we don't understand it based on a specific context, it's very difficult to address the systemic barriers. And based on our experience, understanding these factors can be achieved by analyzing complex socio-economic, ecological, political contexts, which embedded multiple subsystems where climate change adaptation is embedded. And these in turn have to identify the systemic barriers and also opportunity to irrigation under the climate change impact. And secondly, these systemic barriers, opportunity and solutions for those related are large scales and interdisciplinaries and uncertain, requires intervention that cross scales, cross level and cross sector, but context dependent. In agriculture, for example, the focus is on climate change, climate smart agriculture, but they are still look at the traditional ways and wondering why farmers not adopt to those climate smart agriculture innovation. Risk related to climate change in agriculture come from many ways and affect many agricultural value chain and act across the change. Excuse me. Sorry, I'm in another meeting, that's why. At the farm level, for example, with ongoing weather uncertainty, farmers are already investing in irrigation to support their farming produce. Their investment, however, are informed by water need and market demand. And therefore, supporting smallholders' climate adaptation depends very much on the functioning of agricultural value chain, no longer at farm production level. And then farmer ability to overcome those barriers and take into account opportunity that can make their investment best out of their investment. At value chain levels, private sector business innovate their financing instrument to enable farmers' investment. One of example, which is pay as you go for solar power irrigation pumps, have been leading by private sectors companies in many countries in Africa now. And another is win-win partnership between public and private sectors, also a key for this scaling or make the irrigation technology and smart agriculture innovations available for farmers. Thirdly, the large-scale adaptation to climate change needs an enabling environment that create and facilitate supportive technical, financial, and institutional environment to accelerate the climate adaptation. To reach the scale in a sustainable and inclusive manner. For example, financing modality need to be put in place and bundled with other smart innovations for farmers to invest, and creating such environment can be achieved by having right people sitting around the table so that all can respond to the dynamics changes during the adaptation processes. And it requires strong inclusive policy processes, win-win partnerships, and well-functioning market that allow the investment into the efficient investment into the adaptations. And lastly, I want to highlight that there is no silver bullet that fit to everywhere in regard to climate change adaptation. We need to be responsive to the contextual needs and changes, dynamics, contextual needs and changes, and be willing to co-learn and also strengthen capacity, be inclusive to actor and vendors, identify and mitigate investment risk, and define the impact. So effective adaptations must address large geographical scales, but also connect across the scales and sectors. Based on our experience with farmer-led irrigation development scaling in Ghana, Ethiopia, and Mali, we see that an adaptive scaling approach allows adaptation processes to engage with such different strategies mentioned above. And these diverse strategies also allow the capitalization upon on potential synergies and also minimizing risk and diverse trade-off at scales. The adaptive scaling approach also leads to transformative ways of investing in designing, organizing, applying action research approach for development to achieve transformational changes, which impact a wider food system. Yeah.
Thank you very much, Min. You've said quite a lot of things. I tried to pick a few of them. You've talked about the fact that the complexity with climate change requires a systemic approach to climate change adaptation, and that it is important to address the systemic barriers and improve enabling environments. You talked about having interventions across scales, levels, and sectors. And you talked about the adaptive scaling approach that you have used in different African countries, which you have used specifically for the farmer-led irrigation as a way of adapting to climate change, and also mitigation as well. So thank you for sharing your experience with us. Please, there are some questions that are there now on the Q&A box. I want to pass on to my colleague, Evaristo, to help us manage those questions. Some of them have been answered directly, but a lot of them have not been answered. So over to you, Evaristo. Can you just help us through those questions? Thank you.
Thank you very much, Funke. And thank you, colleagues, for submitting a number of questions. So I'll start off maybe by questions which have not yet been answered, and maybe in the interest of time. The first question that I would want to read is that what are some of the specific technologies employed by you and farmers at the different study sites? I think this is specifically for Sanda. I'll try to read 2 or 3 questions so that we take them together. And then the other question, this one I think is for Prof. How do we measure the major causes of climate change? And in brackets, they're talking about greenhouse gases. And maybe I'll also take, there was another one which was also related to, that on the greenhouse gases. And this one is from Rogers Muyambi. And he said, for climate smart water solutions, have you taken into account the greenhouse gas accounting? So maybe we could start off, Sanda, do you want to go first? And then Prof, you could also respond, especially on the aspects on climate change as well. Sanda, over to you.
Thank you, Evaristo. Yeah, I'm responding to some of the questions that are put there. In terms of technologies, irrigation technologies that we scale, they should be affordable. So we try to scale low-cost solutions that are easily to install and to use by the farmers. One successful example is the introduction of shallow tube wells, which are commonly used in Nigeria, but they were not used yet in Mali and Burkina, or at least at a very small scale. And it allows farmers with a relatively small investment of $600–800 to tap into the shallow groundwater resources and irrigate 1 to 2 hectares in the off-season. This is what we introduced there, and a lot of interest from surrounding villages to invest in such technologies as well. Another example I would like to give is the chameleon sensors. These are sensors developed in Australia, and they have been tested a lot by IMI. across Africa, low-cost sensors, let's say $50 that are put into the soil, and the farmer can read out those sensors with very simple blue, red, and green lights. And that gives an indication to the farmer whether he or she applied too much water, the right amount of water, or actually too little water. And it's an auto learning tool, so farmers deploy it and they know that the next time they have to pump a little bit longer or a little bit shorter when they apply the water to their crops. These are some of the technologies. IMI is also working a lot on solar solutions, so scaling solar solutions, solar irrigation kits, which we do with private sector partners by developing sustainable business models around it. So that's another solution that we test. I think I should leave it here.
And thank you, Sander. And maybe just a small follow-up. I'm trying to link with what Timo was mentioning in terms of affordability. For instance, you are talking about USD $50 for the sensors. How affordable are these in some of the study communities?
Yeah, we try to offer them as bundled solutions. So together with the investment in the irrigation, if you see it in that way, then actually the sensors are relatively cheap, especially when there's an incentive for farmers when they pump water, when they have to pay the fuel for the water. Learning to apply the right amount of water instead of over irrigating, which is often happen. Then such an investment can be earned back rather quickly.
Thank you very much, Sander. And Prof, over to you for your response.
Yeah, okay. Thank you very much, moderator. I think Sander also mentioned some of these technologies. Just to add up to what he said, I think the question is, how do we measure the major causes of climate change, referring to the greenhouse gases? And I do respond that, of course, there are instrumentation methods, and I think Sander already mentioned the various sensors which you followed up, but more importantly also, there are also models to measure greenhouse gases, carbon dioxide, methane, water vapor, etc., in the atmosphere. We have various methods. The WRF model can also be used. We have used this at the competence center to do some measurement. And also there are satellite information on availability of greenhouse gases data scattered all over the place. So we have also remote and GIS measurement in order to supplement whatever we are getting from ground observation. So those are three other additions that I want to have: the model results, the remote and GIS measurement, and also information of greenhouse gases from the satellites. Yeah, back to you.
Thank you very much, Prof. and Sander. Maybe we could move on to the next questions. I know some of the questions you are already starting to work on them, but in the interest of time, maybe we might also ask, like for instance, Sander, I know you are working on this question about, you've just responded to it. Okay, but I think the key, maybe if you could just briefly highlight the issues that has been raised in terms of the connection between agricultural water and domestic water, that we are focusing more on agriculture and we're not saying anything on domestic water. Could you respond, I think, briefly? I know you've already, just in the last minute, I saw that you responded to this.
Yeah, thanks, Everest. I was indeed typing a response to that question. This webinar focuses a lot on climate smart water solutions, for agriculture, livestock, and so on. But of course, the change in climate also changes the availability of water for the domestic users. And in irrigation systems, domestic users are another principal user of the water resources. IMI is doing a lot of work, a lot of research on multiple use of water resources, and also on landscape planning. So the landscape planning of the water resources. So ensuring that if there's an intervention like the development of a small reservoir, that we don't only look at the construction of the reservoir and then we're done, but also who is going to use the water resources, who will have access to these water resources, and how will it change the relations between the users. And that is of course the farmers that use it for irrigation, but also the herdsmen that water their livestock, and of course the domestic users.
Thank you very much, Sander. And before I go to the next question, I wanted maybe something which ties all the different questions and maybe linking also to the comment which was also made in terms of irrigation efficiency at local level versus what happens at the landscape level. Or maybe are we talking about being penny wise and then being pound foolish in terms of what we are doing? So I wanted, but this is not just for agricultural water management. Prof, if you could also respond to this in terms of what we are doing in terms of climate change at our small level. How does it add up to the broader landscape level, at a broader continental level? And maybe Sunday could also maybe comment on that later as well, in terms of what difference does it make, what we are doing on a small level and at the landscape level, what does that mean? Prof, first and then.
Yes, okay, Evaristo, thank you. I think the effort we are making is quite large and useful in the region on the small scale because I think some of our research activities are targeted towards different adaptation practices for water, agric, and also coastal zones of the various regions. I know that Hilmi is working very well on this, and also WASCAL, we are also, building this kind of adaptation strategies and trying to develop services, from all these strategies and find a way of getting it out to the farmer. So if I get your questions very right, so either at the regional level or global level, I believe our two institutions, for example, are contributing very extensively into all this in trying to see how to mitigate against the various implications of climate change that we are talking about. For example, I think Ojime Lukwe was asking about the various adaptation and mitigation levels that could be used for periodic flooding. I can tell you that WASCAL has developed different of these, especially in the Sahel region. We talked about the sand bonds, the SAI method, if I get that pronunciation right, pardon me, the sand dune stabilization. All these are the various technology that we have built right in WASCAL, and I believe that Hilmi is also working on these water conservation methods. And we are trying to pass this to policymakers, to farmers, in order to, practice all these ideas in order to mitigate, against all these effects of climate change that we are talking about. So various adaptation methods have been carried out right on agriculture, water, and coastal zones in various regions. So I think at the regional level and global level, institutions like WASCAL and Hilmi, we are working hard in providing solutions to this problem. Back to you.
Thank you very much, Prof. And before maybe I go to Sander, just a follow-up on what you are talking about. And once we talk about the climate change, there's also differentiated responsibilities. How do you take into account maybe social inclusion in terms of taking along the farmers according to...
So we can't hear you well. We're not able to hear you very well.
I don't know, is it much better now?
Yeah, it's better now.
Okay. Yes, Prof, if you could comment especially on the differentiated responsibilities in terms of responding to climate change. How maybe within the context of Africa are we ensuring that we are including everyone in terms of gender and social inclusion and looking at the different types of farmers that we have? If you could be brief so that I move to Sander as well.
Okay, thank you very much. Yeah, I think you have mentioned it in terms of gender. Government policies, I think all these are being put on board in order to reduce the effect of climate change within the region. For example, WASCAL that I know, of course, I know that we have come through with different NGOs, not governmental organization, IGOs, which we have come together and build solutions around the problems of climate change within the region. And then we have passed this, like I said earlier, in terms of a policy to government. And I think you mentioned about the issue of gender and youth. Of course, they are most affected, especially the women, you know. So all these we take into consideration in our science, in our research, and in our output. And I think those various areas we have implemented this, and you know, trying to see how we can provide solution into the effect of climate change that we observed and discussed this afternoon. Back to you.
Thank you very much. And Sanda, if you could be very brief, we want to call upon Min, and we would also want to ask Timo maybe to also make some comments as well. So Sanda, briefly, please.
Yeah, very short. You know, IMI works along various scales. So we work on field level, we work on basin level, national level, sub-regional community level. So whatever we introduce at field levels, you know, we try to assess what is the impact at community level. For example, if we introduce a technology like water pumping, you know, we extract water from the system, and if one farmer does it in a lowland, then it's fine. If 3 do it, then it's also fine. But if 200 farmers see the technology and believe it's a suitable technology for them and they adopt it, you know, then groundwater levels may start to decline, and that is definitely an issue. The way forward with that, and that is also what we propose in a new regional initiative, is the landscape planning, bringing together all the users of the water resources, and that's not only the people that irrigate, but also the domestic users, the downstream users, you know, to develop sustainable water management plans, and that using all sets of participatory tools, participatory scenario development, mapping, modeling, multi-stakeholder platforms, to ensure that whatever we introduce is done in a sustainable manner, and that it doesn't create negative impacts on the other users of the water resources. Thank you.
Thank you very much, Sanda. Min, over to you, please.
Yes, thank Everestos. I would like to discuss a little bit on how to make any intervention inclusive to gender inclusion, for example, to resource limited farmer, etc. Our experience show that if we do market segmentation, if we do farmer segmentation, if we do technologies like segmentation, we can be able to connect these different segments together. And we can be able to bundle different innovations to target the right group of farmers with the right need in the right way. And today we have multi-stakeholder dialogue in Ghana regarding sustainability of cocoa systems. And we learned that in order to address smart climate change, smart cocoa system, it should be started with cocoa system segmentation first, in order to understand which system already efficient, which system is under efficient and need what kind of irrigation, what kind of irrigation technology in order to fit with a certain farmers' cocoa production system. Yeah, so market segmentation is really a key for all different actors and stakeholders involved in the climate change adaptations. Yeah.
Thank you, Min. And before I hand over to Funke, I have just maybe for Timo. I didn't get specific question for you, but from the chat. But I also wanted to ask from maybe from a donor's perspective, in terms of looking at, you were mentioning use of local technologies and local knowledge systems. On the other hand, most donors are demanding greater impact, which in some cases is more of they are looking at figures, how much water has been saved, which might not be aligning with the smallholder farmers' practices. They are saving water, maybe it's not as high as the new technology. How do you sort of help strike a balance, especially for organizations which are looking for funding? How do you, maybe from your funding aspects, maybe try to convince the other colleagues to say, well, these figures, percentage saving might not be high, but it's also sustainable. Could you comment on that?
Absolutely. Educating donors is, I think, a key thing that needs to be done. Because there's a lot of people who talk water who don't understand water, who haven't had their feet in the mud themselves. Same with climate. We all talk about climate change adaptation, but very few people high up know what we're actually adapting to. So please continue educating donors. I'll do my best from my side. We need solutions that work, and often those are cheap. That's a problem not just for donors, but also for international companies that give advice, because they often come with expensive suggestions as well. But where I think donors can really contribute, the issue is scale. And we need to get to very large scales to really make a difference. That requires patience, and that's another thing. All our project-based stuff with 3-year deadlines works against letting things grow exponentially when you work with communities. But that's the only way to do it in vulnerable areas.
Thank you very much, Timo. And on that note, and thank you to all the panelists. My apologies, we won't be able to cover all the questions, so I tried the ones which had not been responded to. So I hand over to Funke. Funke, over to you for the final statement.
Thank you very much, Riso, and all participants and panelists and presenters for your presentations, for your sharing, for the lessons. To just highlight the main thing that are coming out, quite a lot of things are coming out here and we have recorded it. So please ensure that you have your name and your email address so that we can give you a kind of a summary of what we have that have come out, the highlights of today's meeting. But basically, we've seen that climate change impacts and scenarios in Africa is predicting extreme warm and wet conditions with increasing competition over natural resources in the coming years, particularly in the Sahel, but also in North Africa and other parts of Africa, that it is actually necessary to adopt appropriate water innovations for building climate resilience across scales. This we have to do bearing in mind the complexity that is involved, using intersectoral approaches and landscape approaches, keeping water on the surface, using low-cost, affordable options that farmers can easily adopt. And I learned also something from the donor himself, from Dr. Gazbek, that we need to continue to also educate, the donor, inform them with what we have, the observation from the field, so that they can begin to think about longer term funding scenario, not necessarily just like three-year project that probably we may not be able to get to impact. I mean, we need impact. We need to be able to reach scale to be able to have impact, and that is very, very important. So quite a lot of recommendations which are very useful. I can assure you that this recommendation and the actions that have been proposed here will surely be part of the ideas and solutions that we want to elevate to the highest possible levels during the forthcoming COP26. We're going to have another session on the 9th of November, and we're inviting all of you during the Agric Water Food Day through the Water Pavilion. We're going to have a session where we're going to kind of present some of these ideas and add on and bring it to another level beyond what we are discussing here until it gets to the policy arena. So please join us on that event. We will also let you know when the time comes. So the next webinar in the series, it's coming up just the day after tomorrow, Thursday, 21st of October, and it will be focusing on boosting synergies and managing trade-offs in food systems. We know that our climate, biodiversity, and food systems is very, very important, and they are all linked. So this forthcoming webinar, we discuss how we can actively strengthen synergies and better manage trade-offs between the social, economic, and environmental outcomes of food and agriculture systems. So join us on Thursday for the seminar, for the webinar. Please register if you have not done so. I want to thank every one of you for your participation today and your contribution. It's been a very good learning for all of us, and we will be sharing with you the final outcome of a notes and summary of today's session. I think all the questions have been answered, and if there's any specific question that you still have, feel free to get in touch with us via email, and we will try to respond. Thank you very much for your time, and have a good afternoon or good evening as the case may be. Thanks to all the resource persons as well. Thanks and bye.